So let us take a second concept. So this is the concept in which we have to prove this x is equals to y is equals to L by 2. What does this actually means? Let me explain you. See, earlier the vessel was at rest and we have to find the point about which, when this vessel is accelerated by acceleration a, the water surface inclines, means it rotates. Suppose this is the point on this surface about which this water surface rotates and get inclines like this. So from this situation, this was our point about which this inclined surface rotate. Suppose this point lies at a distance of x from this side and at a distance of y from this side. We have to prove that this point is actually midway between these two sides, means at a distance of L by 2 actually from both the side, about which this inclined surface rotates like this. So to prove it, we will be using the condition that volume, so here is the proof, that volume of liquid earlier is equals to volume of liquid after the vessel is accelerated. So let us use this condition. Since no water is added and no water has been removed, so the volume of water which is present earlier will be equal to the volume of water present after accelerating this vessel. Okay. So we will be using this condition. Suppose earlier the length of water column was h0. So clearly after giving it acceleration a, water inclines itself like this. Suppose earlier surface was like this at a depth at a height of h0. So let us calculate volume of water in both the situation and equate both the situation volume and evaluate for x and y in terms of L. So let us do that. So volume of liquid earlier, this vessel will be a three-dimensional object like this. So it will be having a height, a length and a breadth as well. Suppose this breadth is b, water is filled like this here also. Suppose this breadth is b. Now let us write the volume of liquid earlier. So volume of liquid earlier will be LB into H, L into B into H. So it's a volume of cuboid actually. Now final volume, this time this is actually a trapezium. This was H0. This was old surface like this, which was H0 actually, and this point is away from this surface x and from this surface y, and this total length was L given in the situation. Actually this will be 3D. It will be looking like this and this will be B. So this time this 2D view will be a trapezium. This is the first base and this is the second base and this is a height of this trapezium. Actually this trapezium is like this, but now it has been inverted like this. So we have to find the volume of this trapezium. So I have redrawn the diagram. So this is the section of water in the shape of trapezium. This earlier height was actually h0 when vessel rest, and this length was L, and this is a 3D view of that trapezium, and this length we have taken it as B, and our earlier volume was LB H naught, because earlier you can see it was a cuboid, but now it has accelerated. So we have to find the final volume which is in the shape of this trapezium. So what I have done, I have just inverted this trapezium so that it will become easier for you to calculate its volume. I have inverted this trapezium, and now I have inverted like this. So now it looks like this. This horizontal length become vertical in this diagram. Point was away from this side y, and this point is away from this side a distance x. So this whole length was L, which is actually height of this trapezium, and this H naught was the length of water column when vessel was not accelerated. So I have redrawn by dots this H naught. So now, considering this trapezium, let us calculate the volume of this trapezium. So what is actually volume of trapezium is half of base 1 plus base 2 into height. Suppose this is our base 2 and this is our base 1, and we all know that height of this trapezium, it's a type of rectangular trapezium, so height of this trapezium will be L only. So this height will actually be L. Now we have to calculate the length of base to evaluate area of this trapezium. So actually this base 1 length is this, and the base 2 length is whole. This whole length will be the length of base 2. To calculate the length of bases, we have to anyhow calculate in this side we have to calculate this small gap length, and on this side we have to calculate this, so that we can subtract it from H naught and calculate the length of this as well. So how to calculate? So we will be converting all the situation in terms of y and x only, and no other variable will be taking. So how to calculate this length? So let me draw this situation here. So consider this small triangle. Can you see this small triangle? So I am redrawing it here like this. So in this triangle, this length, this is the point about which water is rotating. So this was x that we have taken, and we have to calculate the length of this part so that we can put it here and calculate the length of this piece. So how to calculate it? So we will be using alpha. What is alpha? Alpha is the angle with which this water surface inclines with respect to horizontal, and if this is alpha, then in this triangle by corresponding angle this will also be alpha. You can calculate it. That means this is alpha. Let us say this length is a1. So a1 divided by x is equals to tan alpha. So a1 will be equal to x tan alpha. Okay. Now similarly in this triangle, this small triangle, we have to calculate this length so that we can calculate this base length by subtracting it from h naught. So how to do that? Let me make the triangle again. This triangle look like, and this is a2. So a2 divided by y again will be tan alpha only, and a2 will be y tan alpha. So this is the second thing. So clearly now we can calculate the length of these bases. I am redrawing it here. So in this trapezium, this base 2, this was our base 2. Base 2 will be h naught plus x tan alpha. Okay, and this base 1 is starting from here till here, will be h naught minus x, h naught minus y tan alpha. Since this small section is y tan alpha, I've subtracted h naught from y tan alpha from h naught. So this base 1 will be established like this. So now it is done. we can easily calculate this volume of this trapezium. First of all, let us calculate area of this trapezium, and we will multiply it with b to calculate the volume of this whole section. So how to calculate it? So area is half of base 1 plus base 2, this base and this base, that will be 2h0 plus x minus y tan alpha into height of this trapezium. Height of this trapezium is x plus y. From this triangle you can clearly see x plus y, or we can replace x plus y with L. So L. Okay. So this is the area of trapezium, and volume of trapezoid, the 3D part of trapezium is called trapezoid. So volume of 3D figure will be this area multiplied by b. So you can clearly see in this diagram that this area multiplied by this b gives us the volume of this figure. So area into b will be the volume of this figure. Now let us equate old volume is equals to new volume, as no water is added or no water is removed. Old volume was volume of cuboid LBH0, and final volume is area into b. What is area? Area is this whole. So b and b will cancel out. So let me evaluate it. It will come out to be h0 plus x minus y tan alpha divided by half into L. This L and this L will cancel out, and this h0 and h0 will also cancel out. Since this h0 we will be taking here, it will cancel. What will remain here? X minus y tan alpha divided by 2 is equals to 0. So this tan alpha by 2 will go here and it will become 0 only. So x is equals to y. Now x is equals to y, and also from the figure you can see in this figure that x plus y, or here x plus y is equals to L. Okay, so x plus y is equals to L. We will be substituting x is equals to y in this expression. So let us put y as x. So 2x will be equals to L, x will be equals to L by 2. That means the water surface, this was the water surface when no acceleration was given, and this was the water surface, and this was the point about which this water surface rotates. So this point is actually at a distance of L by 2 from the container surface from this side, and from this side also it is at a distance of L by 2 only. Means it's this point about which this water surface rotates, it at midpoint. So you can utilize this concept at many places. It will be a highly helpful concept to remember it as a point. So let us take the third concept, quite similar to the last one only. In this situation, what we have to prove, suppose this length they have given as x and this is y, we have to prove x as equals to y. I am explaining once again. Suppose this was the length of water earlier. Now water surface inclines like this with respect to earlier length. The earlier length was like this with respect to this point. So it rises by some length. Let us say that this length is x, and it also falls by the same length, means x only. So that's why we have to prove this x as equals to y clearly. So let us, without wasting time, let us prove this. We will be using the same method, volume earlier is equals to volume final in this situation only also, and we will be expressing all the variables in terms of x and y only, because we have to prove x as equals to y. So let us calculate the earlier volume. What was earlier volume? It was LB, and the final volume will again be of trapezium only. This time we have been given all the condition already, all the bases and heights already. So height will be L only in this situation also, and this base 2 will be h0 plus x, and this base 1 will be h0 minus y. This is h0 and this small depression is y, so this base 1 will be h0 minus y. So this is our trapezium like this. This is h0 plus x and this is h0 minus y. These are the two bases. Let us put here h0 plus x plus h0 minus y into the height of this trapezium. Height of this trapezium is L, so into L. Now clearly L and L will cancel out. Sorry, don't forget to multiply B as well, because we have to calculate volume, not area. So this three-dimensional view will be we will be having B as well, the depth of water. So L into B. So from both the sides L and L will cancel out, B and B will cancel out, and let us multiply 2 here. So 2h0 will be equal to 2h0 plus x minus y. So from here 2h0 will also cancel out, and this will yield x is equals to y. Means the inclined surface of water rises and falls by same height. If it rises, that means if it arises by a height x with respect to earlier condition, okay, then it also falls by a depth of x only. Now here is a small question. Suppose this is a section of accelerated vessel. This whole height is h1, and this whole height of this section is h2, up to which water has been inclined. Suppose the earlier length when vessel was at rest like this was h0 only, means this length h0, and this base length is L. So we have to express this height h1 in terms of this earlier length of water and this the length of the base, okay, and similarly h2 also. You will be knowing that in solving the accelerated vessel problems, we were frequently using these heights h1 and h2 like this. So now we are expressing these heights in terms of earlier variables when vessel was at rest like this. When vessel was at rest, so we will be expressing this h1 and h2 in terms of h0 and L only. So how to do that? So we know this is the water surface goes up by a height of x, and it also depresses by a height of x only. So clearly h1 will be h0 plus x and h2 will be h0 minus x. How? h2, this is h0, the earlier length of water, minus this x, which we have proved here that x will be same in this situation. Now we have to find this x, eliminate this x also, and express in terms of L only. How to do that? So we will be again using the second concept. Consider this small triangle. So this was our x, and this is the point about which water has rotated, and we know from this surface, this side of this section of vessel, this is a distance of L by 2 away. This point is at a distance of L by 2 from this section. So clearly x divided by L by 2 in this triangle is tan alpha. This is actually alpha from corresponding angles. So x will be L by 2 tan alpha. So from here clearly h1 will be h0 plus L by 2 tan alpha, column h0 and L. In terms of those things we have expressed this. So sometimes in question they may give you the earlier situation and they may give you the accelerated situation. So to find this heights, actually this h1 and h2, the final heights, you have to utilize this older condition, older variables only, h0 and L. So I hope these usually ignored miscellaneous concepts are clear to you. You can utilize them anywhere and anytime while handling the problems, and you should remember these points. These will help you in problem solving. So thanks for watching. Please like, share and subscribe for more videos.